Oh, well, hello. Welcome to week 4. I hope you had a happy Easter. And we're back and we're going to talk about light. So we had the whole electromagnetic spectrum. But now what we're going to do is we're going to zoom in exclusively on visible light now. The visible stuff, the stuff we can see. So the radio waves, they still exist. The gamma rays, they still exist. But we're going to look at that thin sliver of the light that you and I are very fond of, visible, the visible part of the spectrum, visible light. And so when we do that, we have this thing called color. You know what colors are? You learned about those once upon a time, right? And so those colors, they are invented by the brain. So we have these transverse, remember that word, transverse waves coming and hitting us in the eyes, different frequencies, different wavelengths, and those frequencies and wavelengths, they would be all jumbled up if that's how they just entered our head. But what our brain does is it just sort of wipes it all and creates a color out of each one, and then those colors make up images. See, we have to sit there and go, all right, this is what my brain does with this stuff. It makes sense of it by creating images so that I can recognize things, so I can recognize red from blue, and I can distinguish in nature good things and bad things and all sorts of things based on how they look. All right, so the three primary, well, we're going to get to the three primary colors, red, blue, and green. What they make up is white light. So when you add different lights together, it produces white light, and you produce them all in equal amounts. Imagine if I gave you all a box of crayons, the big one, you know, with the pencil sharpener in the back. All right, you have all those colors. And each one of those crayons, though, I replaced with a flashlight instead of each color. So instead of a red crayon, you had a red flashlight. And instead of a blue crayon, you had a blue flashlight. If you had a whole box of those flashlight crayon box, and I gave one to each of you, you each have a different color flashlight. And I say, shine your light right here. Now, if you have the red flashlight, well, then it would show up red. Now I say, somebody with the blue flashlight, somebody with the green. And I have everybody shine it on the wall. Question, will it get brighter or darker? When everybody shines their light in the same spot, will it get brighter or darker? It will get, well, it's all light. It's not going to get dark. It's going to get brighter. And the brightest color you can have, when you do it all equally, is white. It's the brightest color. Now, if I handed everybody a red flashlight, well, then it would be really bright red. If everyone had a blue flashlight, it'd be really bright blue. But if I give everybody every color and in equal amounts, it'll make the bright light white. Light, white. White light. All right, so we're going to have to do this in our minds. Because if I said, pull out your crayons, now let's put the flashlights away. Now we have crayons. Now if I said, everybody take your crayon, now it's not a flashlight, it's a crayon, I say, color on my board here, color on it. And you take your red crayon and somebody else takes their blue crayon. Now we're working with crayons. Will it get brighter or darker every time we add a color? It'll get darker and darker and darker. And the darkest color you can have is black. So what we're going to have to do in our mind, do you see what I'm going to say next? What we're going to have to do is say, is Mr. Blank talking about light or pigment? If he's talking about light, things get brighter. If he's talking about pigment, things get darker. So if I say, if I shine this color light on a red light on a blue berry, see, the red light is light. The blue berry is pigment. So you're going to sit there and go, all right, is he dealing with two flashlights, two crayons, or a flashlight and a crayon? And we're going to play that out here, and we're going to try to have that make sense. Let's first talk about just light. So don't even worry about pigment right now. Just light. If I have a red, a blue, and a green projector, or a flashlight, and I shine them all together, where they overlap will be white. Where the red alone is, it'll just be red. Where the blue is all by itself, it's blue, and the green is just green. But where they all overlap in equal amounts, it will be white. All right. Those red, blue, and green are the only three colors you need when you go to the restaurant and you get the three crayons, the triangle crayons when you go to the restaurant. And they only gave you three to color on your menu. The three they give you are red, blue, and green. Because you can make a lot of colors with those. Those are the primary colors. Primary colors. This projector only makes red, blue, and green. That's all it makes. If I get real close here, it's red, blue, and green. I'm going to show you that in a bit. Your cell phone can only make red, blue, and green light. And your television as well. Back in the day, when people would have video projectors, they weren't small. They were huge. And some were so huge that there were three of them. And one had the red part of the movie, the other had the blue part of the movie, the other had the green part of the movie, and they would all shine on the screen, and they would overlap the same movie, each its own color. And where the certain colors would overlap, if they needed to make white, all three would shine. And if only needed red, the red one would be shining in that spot. It was super cool. Now they just condensed it all into one projector. All right, let me demonstrate this actually. No, let's not demonstrate this yet. I need to get one more slide up before we get to that. Because when you add primary colors, you add all three, you get white in equal amounts. What if you only add two? If you only add two, then that's a secondary color. Secondary color. For instance, now here's the formula. If I take, so the primary colors are red, blue, green, but I'm only going to take two. It could be red and blue, let's say. I will get a secondary color. What will I get if I put red and blue together? Red and blue together would make magenta. Red and blue make magenta. I'll demonstrate this in a moment, but red and blue make magenta. If I take, the next one I'm going to do is blue and, no, it's red and green. I think it's red and green? Yeah, that's the one. Red and green next. That makes yellow, and I'm going to demonstrate that for you. Now that one seems weird. Red and green make yellow, but we'll see. I'm going to show you. And then the last two. So now I have red and blue, red and green. So the next combination, I can't do any with red. It's going to be, the only one I haven't done is blue and green. What's blue and green going to make? Blue and green is going to make that turquoisey cyan. Cyan. This is turquoise. It's like I think of the color of the Caribbean on those white sand beaches. That's the nice, beautiful cyan. All right, let's demonstrate this for you. This way. I'm going to make it real dark in here. Actually, I'm going to make it super dark in here by even covering up the exit signs. All right. That, my dear children, is called red. So there's red. Now please notice, here's my shadow. Red all around, and then behind a black shadow. But let me go through each of the colors just in case you don't know your colors. That, my friends, is called blue. Black shadow, blue light. And then the last one, green. Angle that better. Green light, black shadow. But what if I do two? No, let's do, let's do all three. All right, when I do three, it's white or whitish. These are party bulbs from the Home Depot. So let's not overthink this here. But let's do just two colors. There's red. Now let me add blue. Now look at that. That's magenta. So let's flip between them. Blue, red, magenta. Now watch what happens if I make a shadow. I have a blue shadow and a red shadow and then black where neither get. The blue is on this side of me and the red is on that side. So the blue light has an easier time getting to this side and the red light has an easier time getting to this side. And so where my hand blocks the red light, that turns out blue. Where my hand blocks the blue light, that turns out red. But where nothing gets blocked, just the two all together, that's magenta. Let's do red. There's red. And here's green. That would be yellow. And they say, that's not yellow, that's kind of greenish. Okay, I'll give you that it's kind of greenish. But that's because the green bulb is brighter than the red bulb, because these are party bulbs from Home Depot. But watch. Here's green light. I don't know if you can see it very well. Here's red light, but all around is yellow. All right. Now let's get to, I haven't done blue and green yet. So let's turn off red. Now that's just green. Oh yeah, let me show you that here. So without, that's just plain green without red. Here's with red. You see it does turn yellowish. All right. Yellow. All right, now let's do blue and green. So that's green, here's blue. Without the green, that's the blue. Without the blue, that's the green. Together, it's the cyan color. Not perfect because the green's a little overpowering, but look, I've got my yellow, my green shadow, my blue shadow, and then the cyan here. If I do all three bulbs at the same time, we know it makes white, but what of my shadows? What of my shadows? Let's do all three. Now I've turned on the red. Now look at my shadows. Ooh, it's what you're all saying right now. Whoa! I got magenta, I've got yellow, and I've got cyan. I'm hoping it's coming out okay. Normally you're sitting farther back and you're having a hard time because it's farther back. This time it's because you're on a camera. But I've got three shadows, technically four if you count the black one. Three shadows, cyan, yellow, and magenta. Because two of the colors are getting blocked in each spot. One of the colors is getting blocked and two are getting through. So this one has the red and the blue getting through, the magenta one is, but the green is hitting my hand and can't get through. How neat is that? All right, we're gonna come back to these bulbs in a little bit. All right, now, I have this microscope here. See this microscope, this digital Intel, bum 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 bum, microscope? All right, what we're gonna do is I have this microscope through this cord connected to my old Gateway laptop. And I am going to point this microscope at these colors on my iPad screen. I'm gonna point this, and we're gonna see what the screen looks like if you actually microscoped your cell phone screen or your television screen. What happens? All right, so let me show you. This is a ×10 magnification, and here I'm coming in at red. And all right, now you say, oh, I can't see very well. That's because I'm only at ×10. So let's go to ×60, and we'll look at red. Whoa, how neat is that? I'm trying to hold it still for you. Now, actually, let me hold it vertical here. Okay, so here, I just turned my iPad. Look at those are the red pixels. It doesn't autofocus for me. What if I go to blue? Well, here's the blue ones. All right, to be expected. Green. Green. Now, my, looks like the Matrix. My iPad only makes those three colors. Now, wait a minute. How is it can't make yellow? Well, look what it does to make yellow. Oh, there's yellow. See, I'm zoomed out here. Now, as I get closer, I'm lowering the microscope onto the yellows, and guess what's going to show up when I get real close? Trying to get it just right. The red and greens are lit up. What about magenta? Let me go to magenta. Here's magenta. Blurry from a distance. But when you microscope your screen, blue and red. And then we need cyan. Here, I can zoom it even more. Here, let's zoom it to 200. I'll have to even hold it more stiller. All right. And as I get close, look at that. Blue and green. Now, what about black? Well, black's easy. They're all off. What about white? All three are on. Trying to get it just right. I can get it into editing if I need to. Here we go. And then gray is just light white. Dark white, I mean. They just darken them. So each of those colors can't change. The reds are always red, the blues are always blue. That's all they can ever do. But when you light them up in different amounts, then you can make all the different colors. Alright, here I have a movie. It's Star Wars trailer, I guess, huh? I can turn the volume up a little bit, I guess. Here we go.
We're not alone. Good people will fight if we lead them.
Let's zoom in.
Keep telling me they know me. No one does.
But I do.
Long have I waited, and now you're coming together. Is your undoing.
Alright. That's pretty neat, isn't it?